Hello, hi guys, welcome back to DSL. Welcome back to Data Structures and Algorithms Python Essential course. And yesterday we saw about the stack and its implementation with Q and its implementation. And today, sir will take it forward. I hope you all have revised it once and you all are excited to learn today more. So let's get started. Over to you, sir.
Yeah, thank you, Anshika. Thank you for that the quick cover of topics which we did yesterday. Yeah, good evening, guys. Yeah, good evening, Shivam, Gautam, Jadeep, Shreyansh, Rhythm. Okay, I like your name. Anyway, yeah, Ritik. Yeah, good evening, good evening. Hi, everyone there. So we had done some nice discussion on stack and queues. Let's discuss some few more topics. I guess I had told, right? Yeah, Aditya, hi, good evening. So I have told, I guess we would discuss some kind of, what is that? A tree and graph. We'll have some introduction to trees and graphs. So, yeah, Aditya, thank you. And same from Odisha. So I belong to Odisha, so love from Odisha to you. Okay. So, yeah, let's then get into this our discussion on tree and graph. So, okay, coming to this, yeah, Abhijit, good evening. Uh, so can anyone of you tell me like what is basically a tree? The one which we see while we move somewhere to place while we go for a ride or something which we see beside the road. Is that the thing I'm talking about? So like is it similar to your data structure tree? Who can say this? What is a tree here in data structure? Yeah, good evening, Sagar, Akshay. Yeah, Aditya says, yeah, hi to Anshika. Yes, you can take that, Anshika. Okay. Yeah, okay, so I'm actually waiting for your response. So, what is basically a tree? When I'm talking about data structure, what is a tree? Quality a bit low? I don't think so. Is it clear, everyone? Fine, right? Yeah, okay. One parent trunk with many branches. Yeah, okay. One parent trunk and there would be many branches. Okay, I would like to replace this trunk with node. Okay, so I'll just say one node and there will be many branches to it or many edges to it. Okay, yeah. 18, 12, 3, 9. Okay, I don't know what kind of name is that anyway. So you're saying it's a linear data structure? I'm afraid it is not. Tree is not linear data structure actually. So till now, whatever we have seen, array, linked list, stack, queue, okay, they are kind of linear data structure. Okay, but tree is not a linear data structure actually. It is something else. Tree is non-linear data structure. Also, this graph is also a non-linear data structure. Okay, right. Data is stored in hierarchical manner. Yes, you are correct. Data is stored in hierarchical manner. Okay, one would be a parent of yeah, many child. Yes, Subham, you are also correct. Okay, so I'll take you all to this PPT. Okay, fine. Yeah, so this is you can say okay, I've like given the heading as binary tree because that's what we are looking for. Binary tree is in the syllabus of data structure and algorithm actually that we need the most. But generally, what is a tree? So it is basically a hierarchical data structure. Okay, someone had also mentioned that. Yes, so a tree is a hierarchical data structure that consists of nodes connected by edges. So basically, you can say it is collection of nodes and edges and the data are arranged in a hierarchical manner. Video quality low. Yeah, can you confirm the same, Anshika? Is the video quality very low, or
Sir,
is like there's some issue
I
from their
find it
side?
quite fine. It's fine for me.
Fine.
Maybe his internet connection is not perfect.
Okay, I got it. Akash also says like Akash is saying check your resolution. That means it is fine. So yeah, check your connection, guys. Sharma officials, also your video quality, like in which you are watching. Okay, so yeah, so it is a hierarchical like arrangement of data. Okay, and it would contain like many nodes and edges. So a node may have many children, we can say. That is why we say children, parent, parent, children. So that is an hierarchical data structure. Okay, so like yeah, so one of these trees, binary tree, that can be like binary tree or ternary tree or what is that? Let me go to here. Yeah, so there can be many trees, kind of trees. So binary trees, which we will be discussing, binary tree. Then we can have ternary tree. What is binary tree, guys? Again, binary tree is nothing but like a node can have maximum two children. That is your binary tree. If I talk about ternary tree is nothing but one node can have maximum three children or three child nodes. Okay, that is your ternary tree. Then we can have n-ary tree. This seems like nari tree, but it like you should say n-ary tree, where a node can have n number of children. Okay, n child nodes. Got it? No, it's not like that, Aditya. Like there is no oops concept here. There is no concept of inheritance that the child node would inherit some property of parent node. No, not that basically, but it's just a hierarchy. So hierarchy. That's all. Okay, nothing else. So all this kind of trees we can have like binary, ternary, n-ary, but the thing which we are concerned about most is binary tree. Okay, that is would be like yeah, we would be dealing with binary tree a lot. Okay, and we now know what is binary tree. A node can have maximum two child nodes. That's a binary tree. Okay, fine. If I say that if I give you this node, okay, this is a node whose name is A, and if I ask you whether this is a binary tree, guys, is this binary tree? Tree application, okay, Sridharan, I'll just give you a quick application. You can open your command prompt and like type tree and hit enter. Okay, you can try that. Let me also try along with you. I'm not very sure whether it was in Windows or Linux. I'll just have to check once. So also you try it with me. Yeah, I'm also trying that thing. So just type tree and hit enter. So yeah, it's working. Yes. Okay. So you can see it shows the hierarchical structure here. So it is actually maintaining the tree structure, like a folder. Inside the folder, what are the data? Like it maybe a folder will have a subfolder. Inside there, some more data would be stored. So it would just give you that hierarchical structure actually. Okay, I'll have to stop this. Like it is going on. Okay, fine. So I hope you all might have seen that like by typing tree in your command prompt. So that's yeah. So that's why you can say an application of this tree data structure. So hierarchy, if you want to maintain some hierarchy, tree is like efficient data structure you can use for that. Okay. Yeah. So yeah, coming to this question, when I give you this node A, one node A, and I'm asking you whether this is a binary tree. So whether this is a binary tree, yes or no? Excuse me. Yes, right? This is also binary tree. I said binary tree is a tree in which each node can have maximum two children. There is not like nowhere written that it cannot have any children or any child. Okay, so this is actually a binary tree. If you even if you have one node, so it is still a binary tree. It which has no child. Okay, got it? Fine. So let me go there again. I'll have to clear this off. Okay, guys. Fine. So this is the parent, as I have mentioned here. This is left child and this is right child. Okay, so this is binary tree. Then there are certain like you can say like certain types of binary trees also. You can go for okay. Can you name some binary trees, guys? Before I say to you, can you give me some answer like what are the binary trees? What type of binary trees you know? Can you mention? Yeah, Rutuja, hello. No, Jyoti, that is the condition which we are saying actually that is a very specific kind of binary tree. Not all the binary tree follows that thing. Yeah, Atul, hi. Yeah, okay. So just tell me, guys, what are the different types of binary trees you know? Just tell me, and we can actually have a small discussion on that. Heap. Okay, heap. Okay, fine. No issue. Anything else? Extended binary tree or family tree? I'm not asking you application of tree, guys. I'm just asking you like what about what are the types of binary trees you know? Types. Yeah, Amal Santosh had mentioned one thing, complete binary tree. Yes, that is a type of binary tree actually. Yes, you're correct. ABL tree. Okay, okay, fine. Giving us ABL tree. Anything else? Yeah, the basic ones first. Can anyone say? Skew trees completely full. Okay, fine. Okay, see. So we can have actually a strict binary tree, strict strict, strict binary tree. We can have complete binary tree. Also, we can have full binary tree. Okay, some might be confused with this full binary tree. I think full and complete must be same. That would be some confusion here. But let's discuss a bit for this one. Okay, see this, guys. So, what is the strict binary tree? In strict binary tree, it is say that each node would have either two children or two child nodes or no children. Okay, like no node can have only one child. That is not possible. That is strict binary tree. Either it would have two children or it will not have any child node. That is strict. Okay, strict binary tree, strict binary tree. Then what about like full binary tree? Full binary tree is nothing but it says that every internal node or parent node will have two children, like kind of this you can say. Okay, this kind of you can say. So what are internal node? And I mentioned one point, internal node. What is internal node? Can anyone answer this one? So see, these are the leaf node. Okay, these are the leaf node, and these are the non-leaf node, or you can say internal node, right? And this can be called as the root of the tree. This is root. Okay, the topmost node. This is the root, and the last like lower level, the nodes which are at the last level, which do not have any child, those are leaf nodes, and these are this rest of the node are called as internal nodes. Okay, or non-leaf node. So all internal node will have two children, that is full binary tree, or you can say all the leaf node are present at the same level, at the last level. Okay, so you can say like this is level 0 and this is level 1. This is level 0 and this is level 1. You can say this. So if I have a tree kind of this, so this is level 0, level 1, level 2. Kind of this way we can we can think of. Okay, so if you see that all the leaf node are present at the last level, nth level, then you can say okay, this is a full binary tree. Got it? Okay. Then what about this complete binary tree? So some people might be confused with this complete binary tree and full binary tree. Let me talk about this. See guys, in complete binary tree, it is said that all the leaf node may be present. Okay, all the leaf node may be present at nth level or n minus 1 level. Okay, right? Are you getting my point? Means last level. Okay, all the leaf node will be present either at the last level or last but one level. That is known as complete binary tree. In full binary tree, what happens? All the leaf node will be present at the same level, at the last level. But in complete, all the leaf node will be present either at the last level or last but one level. Got it? That is complete binary tree. Also, you might have heard somewhere like almost complete binary tree and all. Okay, I'll just say that as complete binary tree, not almost or something. So when I say in complete binary tree, all the leaf node would have basically all the leaf node will be present either at the last level or last but one level. So tell me whether this is a complete binary tree. Answer me this one. Say me, guys. Is this a like this one? Is this complete binary tree? Because here all the leaf node are present at the like last level here, like nth level, and all n minus one level. So it kind of satisfies the condition, right? So is this a complete binary tree? Okay, Abhijit says yes. What about others? What are you saying, guys? Yes. Okay. Everybody here says yes, but the answer is no. Okay, this is not complete binary tree, guys. One more thing you need to take care is the node order of filling of the node should be from left to right. You cannot leave the left hand part like blank and fill it from right side. This is not a complete binary tree. Or if somebody says almost complete binary tree. Always remember the order of filling of the node should be done from left to right. I can have this. This is also a complete binary tree. Okay, I'll get my point. Okay, let me actually clear this one. I'll be clearing this off, and I'll give you one example here actually. See, if I draw kind of this way, even this is complete binary tree. But if I draw this is not complete binary tree. Or even if I have this, even this is not complete binary tree because I have left out the left node. There's no left child, but there is right child. That is not allowed in complete binary tree. Okay, please be very clear about this. So these are some of the basic types of binary trees, guys, like strict binary tree, complete binary tree, full binary tree. Okay, and we now know what is the condition for complete binary tree. So one thing we can conclude from here is uh, a full binary tree is a complete binary tree, can be called as complete binary tree. Okay, but complete binary tree, all complete binary tree cannot be called as full binary tree. Or you can say, okay, let me frame this in this way. All full binary tree are complete, but complete binary trees are not full. Understood this point? Is this point clear, guys? All full binary tree are complete because full binary tree is what, like, we know all the leaf node would be present at the last level, and complete binary tree says all the leaf node be either present at nth level or n minus n minus one level. Yeah, it satisfies the condition. Also, this from left to right thing is also there. Anyway, it is already full. So this all full binary tree can be called as complete, but all complete binary trees cannot be called as full. Okay. I hope you followed that, guys. Okay, great then. So I'm erasing this stuff. So okay, I'm not getting it to erase all this thing. Okay, fine. Anyway, so okay, so I'm just giving a brief introduction to trees, guys. So we'll not get into like depth of trees because that is again a very huge like stuff. Huge large number of topics are there. Okay, which can be covered at actually in the advanced course. Okay, because this session I have like kept for this competitive coding. We'll see some competitive coding examples that would like help us a lot. So as we have like now a basic idea of trees, we can actually have a quiz on whatever we have learned. Okay, so yeah, Anshika, can we roll out the quiz actually right now?
Yes, sir. Just a minute.
Okay. I'll also share this PPT link, like the link for the same on the screen. Yeah, guys. So I have shared the maybe link over the screen. If you want to type it, you can type it out, or it would be just shared over the chat. So yeah, it has been shared, guys. Yeah, Bharat, that is one funny answer actually. Who had asked basically? Oh, Nandan had asked what is the use of tree, and Bharat says they are good for environment. Yes, pretty much good answer for that. Okay, so meanwhile you give the quiz. I'll also uh, we'll have a look out for on this actually. So you whatever tree you are seeing on the in the environment, okay, and by the roadside we are seeing the trees. So if you just take it upside down, make it upside down, and that would become our data structure tree, right? So in data structure, root is on the top, and the branches, all the thing, rest of the thing are below it, unlike our real tree. Okay. So if you're kind of maintaining, if you want to maintain kind of any kind of hierarchy kind of thing, so tree you can use actually. Okay. Yeah, let me know guys when you are done with the quiz. So have we also shared in the yeah, Anshika, have you shared over Vimeo the same chat link? Sorry, the same quiz link.
Yes, sir.
Have you
Yes,
shared
sir.
the
I
quiz
have
link
shared
over
this.
Vimeo? Vimeo, not YouTube, because we are running on the both platforms, right? Nandan, in inheritance, it would have some inherited property, which is not there in tree here. So here we are not inheriting anything. We are just storing data. Okay, in a hierarchical manner. That's all. Okay, that is like OOPS concept. That is object-oriented concept. So it is like a different thing as in whole. Okay, this is just a hierarchical organization of data. That's all. Nothing else. No polymorphism. No inheritance. No abstraction. Okay. There is some abstraction if I go to specific, not exactly that oops abstraction, but tree basically can say is an abstract data type. Okay. So I hope you are done, everyone. Of you are done with the quiz. So I guess we can continue with the discussion. Are you done, right, guys? Uh, is my voice audible properly, Anshika?
Yes, sir. You are audible.
Okay, I think my video is lagging a bit.
Yes, sir. Your video is a bit blur, but you are audible.
Okay, fine, fine. Just give me a moment. I'll just get that thing done.
So, guys, till then, I would say that you will be having your exam soon. So, you need to revise the topics which have been told to you. So, keep revising and get yourself ready with it. Over to you, sir.
Yeah, thanks for that information, Anshika. So, yeah, Rutuja asks can we traverse tree? Yeah, of course. We there are several traversal mechanisms like pre-order traversal, post-order traversal, in-order traversal. So any of these three traversal technique you can actually use to traverse a tree. Okay, so the next one, graph. Okay, so as you see here, guys, a graph, you can read it out. A graph is basically a collection of these vertices and edges, vertices or nodes, whatever you can call, and they are actually connected. So they are like connected in some way. So what basically this graph is, so to be very simple, it is also a kind of, or you can say, okay, that is a similarity between this tree and graph, guys. Can anyone say? Can anyone, gaming warriors, please explain depth and height of the tree? Okay, you want me to explain what is depth and height? Okay. Yeah, anyway, okay, fine. I'll get that question. So let's do it. Then we can continue with graph. So many people have this misconfusion that depth is equal to height. Whatever is height and what is that is equal to depth. No, that is not the thing actually, guys. Okay. Height basically would be measured if you are finding height of a node, then you would measure or you would like calculate the number of edges or the length of the path from that edge to the deepest node. That is your height of a node. So you'll ask me like what is the what is the which node is the deepest node? So for that we need to understand what is depth. Depth of a node is nothing but length of the path or number of edges from that node to the root node. Okay, that is the depth. So if you are measuring depth of this node, so length of the path from this node from root, that is the depth, and length of the length of path from this node till the deepest node is height. Okay, got this? So if I talk about height of the tree or depth of the tree, it is nothing but height of root node, depth of root node. The value would come to be equal. Height of tree and depth of tree, the value would be same actually, because height of root node is nothing but it is the length of the path from root node to. Okay, I should not say actually height of the root node and depth of the root node is same, because the height of the root node may be like it would be the longest path in the whole tree. Okay, because length of the path from root node till the deepest node. And if I talk about depth of the root node, so basically you would get what is that uh, length of path from root node to root node, so that would be zero again, right? So uh, so basically, so what we have to do here. So height of the tree is nothing but you can calculate as height of the uh, root node. Okay, and depth of the tree you can calculate as the depth of the deepest node. Okay, basically the leaf node, obviously it would be a leaf node, but you should be like you should take care about the longest path, the node which would be present at the longest path. Okay, or last level you can say. Got this? You wanted to explain this in whiteboard, that thing? Okay, I'll not use whiteboard for this. Maybe I have blank spaces here. I'll be explaining this thing here itself. So let's say this is some tree. Okay, so this is a root node, right? So if I am finding depth of this node, so depth of this node, yeah, so depth of this node is nothing but length of path from root node, from this node to root node. So that is nothing but 1. So depth would be 1. But height of this node would be length of path from this node to the deepest node. Okay, that is 2. So height would be 2. Height of this node would be 2, but depth of this node would be 1. Got it? Okay. Yeah, Simran, there would be some specific date. I think you already have the necessary details via your mail, or it is also there in the community. Okay. So yeah. Okay. So this is the height and depth, guys. Okay, I'll not get into uh, this thing anymore. Let's talk about this graph. Okay, what is graph? Graph basically is a collection of like set of nodes and edges connected together. Okay. Um, can anyone mention like one similarity between this? Like, what is the similarity between tree and graph? Who can mention that? Similarity between tree and graph. And also you can same way mention the difference. Okay, let me ask in this way. Can I call a tree as a graph? Can we call? We have now the definition of graph. So graph, what is it? It is consists of some finite set of nodes and edges connecting them. Okay. Can we call a tree as a graph? Yes or no, guys? Yeah, Sridharan, yes. Not basically to the leaf node, to the deepest node actually. Okay. Don't go to any leaf node. Deepest leaf node you have to think about. Yeah, both have edges. Yes, tree is a graph with no loops. Yeah, absolutely correct, Jyoti. Tree is also a graph. Only thing is, tree is acyclic connected graph. So I have used here two terms, acyclic and connected. What is acyclic? There would be no cycle. There should be no cycle. In a graph, there can be cycle, but in tree there is no cycle. Okay, connected means there should be path from every node to every other node. Path. I'm not saying that there should be a direct edge from one node to another node. There should be at least a path so that I can go like, move from this node to that node via some path. Okay, that is called as connected graph. So acyclic connected graph can be called as tree. Okay, so tree is also a graph. Got it? Graph, yeah, graph cannot be trees because the graph may contain like all graphs cannot be trees. Anyway, tree is a graph, so graph would be can be called as tree. The graphs which contain the cycles like this graph, see here it contains a cycle. Okay, so this cannot be a tree. This cannot be called a tree. Okay, fine. There are some ways in which we, okay, I have mentioned already what are edges, what are vertex or node, so that's all visible to you. So there are some way through which we actually represent this graphs, right? What are the different ways you know, guys, to represent graph? So that might be something, right? Like trees, you can maintain in array. Also, you can maintain that in linked list. Okay, tree can be implemented using linked list, also using array. That's all. Okay, tree data. Screen, yeah, screen is visible. Aditya, yeah, yeah, guys. Others, can you just
It's
confirm the
visible.
same? Is the screen visible? Visible, right? Yeah, screen is visible. Okay.
Yes, sir.
Thank you, Anshika, for that. So, yeah, guys. So tree data can be stored either in array. So we can actually go for array for tree. Also, we can go for linked list for tree. Similarly, what are the things we can go for graph? To store a graph, what can we do? Sridhar, not like no, like even in graph you can also call them node, not an issue actually. Trees also you can call node. Even here it is node. We can say node. Yeah, guys, answer my question. What are the different ways of representing graph? Okay, Amal Santosh. Yeah, you are correct. Adjacency matrix and Varun says adjacency list. Yes, it is correct. These are the ways through which we can actually represent a graph. Adjacency matrix, adjacency list. Okay. So what is this adjacency matrix, guys, and what is adjacency list? Adjacency list is nothing but using linked list. Okay, that's the linked list representation. And adjacency matrix, 2D array. We'll use a 2D array to store this data, actually row column kind of thing, to represent a graph. Okay, so maybe if we have this graph. Yeah, if we have this graph, so yeah, let me name it as A, B, C, and D. So your adjacency matrix can be would be like this: A, B, C, D, and A, B, C, and D. Okay, A to A 0, A to B. Yeah, there is a direct edge. There is a direct edge, so 1. Okay, like basically we are looking for which like is sorry, are A and B adjacent? Yes, they are adjacent. When can we say that two nodes are adjacent if there is a direct edge between them? So A B are adjacent. A C, no, they are not adjacent. So you can put 0. A D, yes, adjacent. B A, yes, adjacent. B B, okay, 0, because same node to same node. So we don't have anything kind of this. So we have to put 0 here. We don't say that B is adjacent to B. That is the same node. Okay. So B to C, yes, they are adjacent. B to D, not adjacent. C to A, not adjacent. C to B, adjacent. C to C, 0. Same basically same node. C to D, adjacent. D to A, adjacent. D to B, not adjacent. D to C is adjacent. D to D, 0. Okay, so see here as in adjacency matrix, this diagonal elements are 0. Okay, got it? So if between any pair of node, let's say A and C, if there is a direct edge present, then for that position we'll put 1 in the adjacency matrix, otherwise we'll put 0. That's all. Okay, and adjacency list, basically using linked list we would like represent this graph. Maybe if we have this node A, so it would contain all the adjacent node. So what is the adjacent node here? It is B, maybe D. A and D are adjacent to A. Okay, then we can have another like B. What is the adjacent node of B? A and C. So kind of this way you can also represent. Okay, so these are the ways of representing a graph, like adjacency matrix, adjacency list. Mostly I prefer actually this one. I prefer this one. Okay, for operations actually. Okay, for operations, this we can use. Actually, you can go for matrix or this adjacency list. Uh, uh, List representation is also fine, not an issue at all. Adjacency matrix is also fine, not an issue at all. Okay, depending on operation you take them. Okay, I don't want to increase the complexity. Complexity, I'm not talking about time complexity thing, but the complexity of the coding. Okay, like for user purpose. Okay, if I talk about the user perspective, so yeah, I'm working with this linked list, like adjacency list, and doing this algorithms of graph and all may be a bit complex. So normally we go for this metrics, adjacency metrics for doing some operations. Anyway, fine. Incidence metrics. Okay, incident metrics. Okay, if you have mentioned this term, let me actually tell you one thing here. See, there are certain types of graph, like what can I say, directed graph, undirected graph. This graph, which I have shown here, this is an undirected graph. There is no directions attached. But if I say this graph, if I say this graph, this is directed graph, or you can say digraph. Okay, directed graph or digraph. So here you can actually go for incidence matrix if the graph is directed graph. Okay, so okay, fine. So I hope we have now a basic idea of graphs, guys, graphs and trees actually. So we'll get into this detail. Like there are a lot of things in this, even in this graph and all. So I don't want to get into that right now because I have to do this. What is that? Sorry, competitive coding. We'll see some competitive coding examples. So I don't want to get into this right now. Anyway, we are covering this thing in our advanced course. So I hope we all of us would meet there once again, and we can carry forward all these topics which we could not cover this time. We can go get into there and do all the things necessary things there. Okay, so as we have now a basic idea of graph, I think we can have a quiz on this graph. So yeah, Anshika, what say we can roll out the quiz, right? Okay,
Yes, sir. Just a minute.
yeah, thank you. So yeah, also I would also share the same. Okay, guys. So I have shared over the screen, and it also like it could also be pushed into the chat section, guys, in a while. Yeah, it is there in the chat section, so you can click on the link, get to the quiz, finish it as soon as possible. Let me know, and we would see some like amazing question in competitive coding, guys. Okay. By the meanwhile, like whenever you are done with the quiz, and if you have some question like doubt or something, some question related to this thing, you can also ask me. Meanwhile, okay. When you of course, like obviously after your quiz, first of all you have to complete your quiz. Then you have to like if you have some question, you can ask. By the time your friends would complete. Not working. Simran is saying not working. Something not went work. Sridharan, a real life application of graph. Okay, it's very like very much easy to say. You know this Facebook, right? So when you are connecting, when you are logging, you see this login screen. That it is showing this many nodes and this connection and all. So you are basically acting as a node. Your friend is another node, and other friend is another node. So your mutuals are there, mutual friends are there. So that is a like different level of node. Okay, and okay, so I have said that thing. Okay, first get onto the quiz, finish it. I would like to have a small chit chat over that Facebook thing. So, guys, just like kind of you can work on reloading the quiz page. Just try to reload it once and check. Just try to reload, guys. Okay, working right, completed. Fine. Okay, so one or two people have like completed the quiz. Guys, like for those who like for those if this link is not working for you guys, just please reload. Try to reload the page, and I think it should work. Yeah, Akash also said like it's done. Vineet done. Aditya says done. Okay. Jyoti said yeah done. So I think most of you are done with the quiz thing. Okay. Meanwhile, like meanwhile your friends are completing the quiz. If you have something to ask, any question, so you can have that thing. Okay. And also, yeah, someone had asked about this like real life example of graph, right? So it's pretty much simple actually, guys. Like I was talking about this Facebook example. Let me just give you quickly this thing. Okay, whether I'll get some place here? No, I'm not getting a place. So best would I scribble? Yeah, I can scribble here. Okay, I got place. See, this is you. Okay, then these are your friends in Facebook. Got it? Then there like some of their friends would be there. Maybe they are these friends. Got it? And your some of your like there will be some mutual friend also, right? So maybe they are connected, mutual friends. So they are connected. Okay? Then they may be connected. So this is a graph. So this is a real life example of graph, like the data, the profiles, or is treated as an individual node. Okay. Degree of any vertex of a graph is. Okay. What is degree? Can't you say what is degree? So if I talk about this node or this particular node, what would be its degree? Nothing but what is degree? Who can say here? I think that's a quiz question. So let's take that question later. I think everyone would otherwise listen to me and just answer there. Okay. Jyoti, I think related to this assignment submit thing, I guess every detail is there in the community link. So just visit the community link. All the necessary details are there. Also, I think you might be receiving emails if you have registered over there. You might be receiving emails. Okay, which would contain like many details about submission of assignment and all. So yeah, guys. So this is what I'm talking about. So this is you. These are your friends. Okay, over Facebook, right? Okay, these are your friends, which like who are directly friends to you, and they might have their friends to whom you are not connected, like this, this, and this, and this, and mutual. Let's talk about this mutual connection. So maybe they are also connected together. So this and this are mutual connection. Okay, right? So that's what. So Facebook also implements this graph theory there. Okay. Also, how it gives you suggestion and all. I'll also talk about that. Not now. Basically, we'll be discussing that in advanced course because that actually is an algorithm basically. So let's not talk about that. Like how it gives you this friend suggestion, how it gets to know whom to suggest you. Okay, that is also basically a a small algorithm, an easy algorithm. That's all. Okay. Yeah, obviously some improvement would be done like by from their side. But anyway, but that is basically a small algorithm which we'll discuss later. Fine then. So we are basically done with this introduction of graph and tree, guys. It's time we get into competitive coding. So like basically we are done with this PPT thing. I don't need any more PPT. Let's go to a Jupyter because that's what I need now. Okay. So I'll create one more file. I hope it's visible to you. I've created one new file. Yeah, you can go with. Even your maps are also graph, right, Rutuja? Map, road maps and all. So a city can be a node. Let's say Mumbai is a city, maybe Pune another city. So the roads and all that is also a graph that can also be kind of like taken as graph example. So each city can be a node, and the roads are edges. You can say. So yeah, this I would maybe give heading as competitive coding. File name is competitive coding. So the first question is, let's say I've been given an array. What array I should take? Something. Some array, maybe the same good old array 96508. This is the array given to us. Okay, so we need to print the array content after k rotations towards left. Okay, this is the question. I hope you are getting the question. What is the question? So given an array, print the array content after k rotations towards left. What is k? K basically would be taken as input from the user. How many times the array, how many times you want to rotate it. And the rotation is left rotation, rotations towards left. So you need to think about it. And that too, I'll add also one condition in Bigo n logic. So might come up with many logics, but I want to do this in big of n, the linear time complexity. Okay, so what is this linear time complexity, guys? So okay, first of all, what is rotation? Let's talk about this. So this is my array. If I rotate this once, so what would happen, guys? Basically, if I rotate it once, what will happen? Okay, so yeah, just a moment. I'll have to like switch to another screen. Fine. So I think you're able to see this. Yeah. So the array here is given as like 965082. So when I rotate it towards left, what would happen? This 9 would come here. Okay. So 6 would come there. Like 5 would be shifted there. 0 would come there. 8 would come there. 2 would come there. Okay, this is like basically left rotation once. So you would have the array content as 65082 9. If you rotate it once again, what would become? Like 6 would come there. So then all this element would be shifted. So you'll get 508296. So second rotation over. This is first rotation after first. This is after second. Let's rotate it once again. So you'll get 08296 and 5. So this is about after third rotation. Okay, so yeah, it's quite easy when k is 3. If I take the value of k as 3, so we need to just rotate it 3 times and we'll print it. But if you see here correctly, for each rotation, what we are doing, we are shifting n elements. So this element is like basically shifted toward here, and all other elements are shifted towards left by one step. Basically, this would each rotation will take big of n. In this method, each rotation will take big of n. And if I say, let's say in worst case, okay, let's say we have to perform k rotations. Each rotation will take big of n. So k rotation will take k of n. So let's say in worst case, k value is n. If I take k value as n, so it would be big of n square, which is not accepted because condition is to solve this question in big of n, right? So what to do here? So what to do here? So what can be done, guys? See, let's say I'll do a different thing here. See, I want to rotate it. Let's say k value is 3. So after third rotation, after rotating it 3 times, what would be the array content? So I'll write here basically indices 0, 1, 2, 3, 4, 5. Okay. After rotating thrice, so what would be the array content? Just look at here. If I write this 082, then if I write this 965, is it the same like answer? Yeah, we'll use list. When I say array here, we would be using we'll be using list, not linked list. We'll use list actually. We're assuming list basically is an array here, so we'll be using list here. Yeah. So guys, is that the same answer when you rotated this thing like thrice? Same answer, right? 082965 after third rotation. I didn't rotated it once and once. What I did is from index 3, I printed till the last 082. Then from 0 onwards, like 0 to 2, I like written all the element. End of this. I'm not rotating it. I'm just printing the element from a certain place. Let's say k value is 4. I want to rotate it 4 times. So what would be the array content after 4 rotations? It would be 829650. From index 4 onward till the end, I'll write first. Then from 0 to index 3, I'll write them. Okay. See, I haven't written the code. This is just a question, guys. So just don't get confused about this. Okay. Fourth rotation will give this. So I'm not rotating it anyway. The question hasn't asked you to rotate the array. It has asked you to print the array content after k rotations towards left. It has nowhere asked to rotate the array. So we are printing the array content 8 to 9650. So it is all about output, guys. In your competitive code, when you are working on a platform, it would match your output with the stored correct output. If that matches, then you would get answer, like correct answer. Also, your time complexity should match. Now it is big of n, right? Now it big of n. But one thing is, let's say, okay, how many elements are there? 1, 2, 3, 4, 5, 6. Okay, if I would say make it 6 rotations, if k value is 6, so what would be would you get if you want to rotate this array, like array 6 times towards left? Basically, you will end up getting the same array, right? 965082. Try checking it. Okay, try checking it. You can check it out. So basically, if you rotate it 6 times, there are 6 elements, and if you are rotating it 6 times towards left, you will get the same original array, same given array. You will get it back, right? So within this logic, if next time if anyone asks you, okay, rotate the array 9 times, do we really have to think about rotating the array 9 times? No, right? Because if you rotate 6 times, you will get the same array. Just have to rotate 3 more times. That's all. Okay, so when k is given, you don't have to exactly rotate k times. Actually, you have to rotate it k modular size time. What is size? The number of element in the given array. So here if size here is 6, so 9 modular 6, that is 3. Basically, you have to think about 3 times left rotation. Got it? Okay. So fine. I hope you got this point here. Okay. So I'm erasing this stuff. Now we can get back to the coding. So I'll share this Jupyter notebook. Okay, that was not Jupyter notebook which I shared. So let's get back to this. Fine. Okay. So anyway, we need to take an array here. So maybe a equal to, we'll go to the same thing in I. Oh, this is also OMB code for I in input dot split. Yeah, you can put some message here like enter values. Fine. So you'll get an array, basically list of values, and k also you have to take input. This would be taken as input from the user, number of times to rotate, enter and the number of rotations. Left rotation. Question is about left rotations. Fine. Then what you have to do basically, so we don't have to exactly find out like rotate it k times. We have to rotate it actually k modulus length of n time. So you can actually find the length of the this thing. So you can say n equal to length. If you want to write it separately, specifically, you can do that. Your wish. Okay, I'll do that so that it would look very simple later. So we have to print from which? So which index? If k is 3, we were printing from index 3. So yeah, very much like easy now. For I in range, where it would start from? Basically, it would start from k modulus n. Here it would start from, and it will go till n minus 1, right? So yeah, this is the thing. For each of this, I can print a of I. But I don't want to like print in separate lines, so I'll just end it with a space. Then after this, one more loop for I equal to I in range 0 to k modulus n. Okay, because if k is 3, I'll first print 3 to I'll start printing the element from index 3 till the end. Then from 0 to 2 I have to print. So from 0 to k modulus n minus 1 position I have to print, right? So if I place here, if I write here k modulus n, then it will go till k modulus n minus 1. So that's the trick here. Okay, print A of I, the same thing, n equal to space. Okay, fine. So if I hit like shift enter, so it is asking me enter values. What are the value we had taken? 965082. 9 say sorry, say 5082. What is that? 2. Hit enter. Enter number of left rotations. Let's say 3. Are we getting the correct answer? Yeah, 9 would be shifted, then 6, then 5. Yes, 082965. Okay. Next, let me check with some different values actually. Okay, so 965082. Fine. Let's now take number of rotation as 4. Is it working? Pretty much, yes. It's working. Okay, guys. So our task is done, and yes, this would take big O of n, because in total, even if you add this up, you would get big O of n. Okay, actually, you have to take like the maximum thing. This would take some time, and this would take some time. Okay, you exactly don't know like how many uh, rotations. Okay, we are not doing any rotation here. In worst case, let's say this loop is also taking big O of n. This loop is also taking big O of n, big O of n plus big O of n. That is again big O of n. So this would take linear time complexity. Okay. Take k equal to 6. Okay, fine. We'll also do that. So the thing 965082. Let's see whether this is working. Yes, it is working. It's the same thing. Okay, what would happen basically is k modulus n. So 6 modulus 6 is 0. Okay, so it would print all the elements basically 0 to n minus 1, and from 0 to 0 nothing would happen. This loop will not, the second loop will not run at all. Okay, and means see, by default this print function of Python has the default behavior of printing the data and taking the cursor to the next line. I don't want to take the cursor to the next line after printing each value. Okay, I want it to end with space. Like it will print 9, then it would end with a space. Then it will print 6 and it will end with a space, kind of that. Otherwise, it will print 9, 6 next line, 5 next line, 0 next line, kind of that way. Okay. Got it, guys? I hope this thing is pretty much clear. Okay, you are talking about slicing, Satish? Yes, we can also go for slicing. Yeah, we can go for slicing actually. So if I comment this whole thing, I was talking like I was explaining the logic actually, so that you can actually do it in both Python and also in C or C++ or Java. If you want to exactly to write in a Pythonic way, so okay, I don't know exactly whether that is a term at all or not. Okay, so you can actually go for printing A. It will start from K modulus n. Yeah, you can leave it like if you leave the end index blank, so it would like print till the end. Then you can actually print from 0 onwards k modulus, yeah, same thing, k modulus n. So when you give end index as k modulus n, it would go till k modulus n minus 1. That's what. Okay, so let's check it out whether it is working or not. 965082. If I give 3, okay, kind of, yeah, this is printing something and this is printing something because we are printing in part wise. But again, so you can like I think you can do this thing. Okay, how can you do this and all. So this is basically a list. Again, this is another list. So you can go for concatenation, guys. So you just put plus between them. So this two things would be concatenated into a single, like it would print as a single list. Okay, that is not a major concern, but see the result. It is working or not. 08 after 3 rotations. The array content is 082 and 965. Got it? Okay. Okay, let me show you. 965082. 3, let's say. Yeah, I'm getting 0829665. I hope pretty much clear, right? So you can solve this question even in C or C++ or Java or Python. So I have given you this logic for C, C++, Java. and also now you have this logic in Python, the slicing thing. Okay, got this? Okay. So see guys, if you don't want to store length of this list in some variable, not an issue. You can wherever you have written n, you can just replace here length of n. That's all. That depends on you basically. Yes, slicing does, not only takes place on string Simra, it also we can apply slicing in list. Also, we can apply slicing on tuple. Okay, so not only on string, we can apply also here in list. This is slicing basically. You have done here slicing. Okay, but the logic is same, pretty much same. So yeah, guys, so I hope you found this insightful, like understood this one, right? This question. This is a good question. Next question is again a interesting question. Okay, so this is known as something called Barua number. I don't know whether you have seen this question anywhere or not. Okay, so some number should be given. Okay, some number should be given to you, and you have to print the result of multiplication of those numbers. But the condition here is there would be maximum one decimal number, or there can be maximum one decimal number. All other numbers would be Barua numbers. So let's first understand what Barua numbers is, and again we would see the question. So what is Barua number? So for Barua number there are few conditions actually. One is first is uh, like contains only 1 or 0. Fine. Then second point is contains only 1 1 and any number of zeros. Noted. This is the second condition. And then third condition is it must start with 1. Okay. So this is Barua numbers. What is the Barua number? Barua number, it is said that Barua number will contain only 1 and 0. It will contain only one number of 1 and any number of zeros. Also, the number must start with 1. So what are the possible examples of Barua number? It can be 1, it can be 10, it can be 100, it can be this, it can be this, or it can be this. So these are all examples of Barua numbers as per the given set of conditions here, guys, right? And it is said like there can be only one. There may be actually at most maximum one decimal number. Maybe example we can say 134. Maybe this. Maybe this decimal number. Okay. So the question is this, and this decimal number may be present or may not be present. Okay, so the question is like basically that can be one decimal number, but all other number would be Barua numbers. And Barua numbers, we now know what are Barua numbers, and you just have to print the result of multiplication of all these numbers. That's the question. Okay. Maybe you can think, okay, this is Python. Python has a great range and we can multiply very large numbers. But let's keep it like generic, guys. Sound like it would work for like anywhere, like C. We'll write a logic which can work over C or C++ or Java or in Python. Okay, that's what. So I'll not write the exact logic here, like I'll not code it, but I would discuss the logic, guys. Okay, but before I write the logic, I would like to know from you what all you are thinking, like what are the ways you are thinking to solve this question. So these numbers are given, and you need to multiply, like show the result of multiplication of this number. So how can you do this question? Yeah, this is decimal number, right, Divya? This is decimal number. This is not the result. Result is you have to multiply this. You have to multiply this, then all these numbers. all these number given. Okay, you have to multiply all these number. Result of product of these numbers. That would be your result. So how do you think, guys? How do you solve this question? Pretty much easy, right? Numbers are given. We have to multiply and display the result. That's all. Am I right? Some numbers are given. We'll just multiply and show the result. That's all. Yeah, Divya, I said there can be one decimal number. Okay. See, listen to the question properly. Some numbers should be given. Okay. There would be maximum. There can be maximum one decimal number. Okay. Rest all number would be Varua numbers. Okay. So decimal number may be present, may not be present. Got it? So whatever numbers are given to you, you have to multiply and show the result. That's what. Okay. So what too much easy question for us, right? So we have number and we would multiply them and show the result. Okay, but just think about, guys, the limit of the values that can be stored in any data type. Okay, Python has a large range, large limit. I understand that, but okay, there would be maybe there would be some point where you cannot be would not be able to store very large value. If you talk about C or C++, yeah, it would take very compared to Python, it would store a very less size of numbers. Okay, so you cannot actually multiply them and store them. Okay, of course there will be some constraint in the question given to you, like the maximum value can be this much long, and total there can be maximum this many numbers. Okay, so that would fall in the limit actually. Yeah, engineer Guruji, I just said the same thing. 134, that is a decimal number. Why it needs to contain only 1 and 0? So what we need to do is, okay. So it might look very easy question, like okay, numbers are given, we need to just multiply and show the result. No, that's not very easy that way. We cannot. Maybe you when you multiply, there's many things, there's many big numbers. Maybe you would not be able to store the result somewhere to display it, guys. Okay, so it's very simple. You just need to think how you do it in real life. How you do it in real life? My bad. Okay, I need to do it here. So if I give you some numbers, let's say I'll give you numbers 1000 multiplied with 135000. So would you basically multiply these numbers? No, right? We don't multiply the number. We know that answer is 135 and 0000, and it has 70. Some 0. Okay, fine. So kind of this. No, 0 is not Barlow number. It should start with 1. Abhijit. The condition is the number should start with 1. So this is it, right? We are not actually multiplying them. We are not doing 0 into 0, then 0 into 0, 5 into 0, 5 into 0, 5 into 1, like how we do the exact multiplication process. We are not doing that. We just know that, okay, this is nothing but 135 into 1 is 135, and rest all, we just have to count all the zeros and put it here. That's all. That's the same thing which we have to do here when we are coding actually. So you just have to count the number of zeros, guys. So here there is no 0. Fine. Okay, you multiply 1 and store it. Then here you count the number of 0. Okay, we have found basically 1 0. So yeah, we have found 1 0. Okay, I'll just show you a screen, guys. Just give me a moment. Snippet. Yeah. Fine. Yeah. So I have this 1 0. First I had 1, then I have this 100 maybe, then I have this 1000 maybe this, and I have one decimal number maybe this. Okay. So we'll take a count. Okay, this is 1 basically. So okay, fine. So this is P. Initially P value would be 1. So just multiply this 1 with P. So you are getting the same 1. Then from we are at this number. So now let's count. Okay, there is 1 0. Fine. Then left out. So we count 0 and delete it from this number. So you are left out with 1. So just multiply it 1. multiply it with the previous value of p, so you'll still get the same one. Then you count 1, 2, 3. Oh, we didn't. Yeah, okay. 3 more zeros, so total count is 4. And the value of product is like now still 1 into 1 because left out with 1, right? And then we have to count these many 0, 1, 2, 3, 4, 5, 6. Total count of 0 is 10. So left out is this, so into 1, okay, p value still 1. Then come here, 1, 2, 3, 4, 5, 6, 6 more zeros, so 16 zeros, and you multiply this 134. So 134, that is okay. 134 is what is the result of this non-zero part. You can print it now 134, and rest of you can print 16 zeros. Run a loop for 16 times or c times and print those many zeros, and your task is done. Okay, right? Akash, so we are not talking about how the numbers are stored, how the data are stored in the machine. We're talking about what numbers we are given. That's all. Abhijit, again I'm saying there can be one decimal number, and decimal number may not start with 1, it may not contain only 1 and 0, it may contain some other numbers. Result. Now result is this. Result of multiplication of all the numbers given. Okay. So this obviously we can easily store these numbers 134. That will not do a big deal. That will not require much memory because we have just counted zeros. Okay, 16 zeros are there. So we can just print number of zeros. We can run a loop for c times 16 times, and we can print 16 zeros. That's all. Understood this, guys? Is it clear? Okay. So I hope this thing is clear, and I think you can actually write the code for this by your own because this is not very difficult. Okay, we have seen this thing. Uh, okay, Divya, what are we exactly doing? We are basically doing the multiplication of these numbers. That's all. Only thing was the numbers were very huge, and there are very large number of like you can say many numbers, that too very large. There can be maximum like maybe 10 to the power 6 numbers given to you, and each number can be 10 to the power 18, as big as 10 to the power 18. So just imagine here that you have 10 to the power 6 numbers, and each number can be as big as 10 to the power 18. Can multiply these numbers and store and display, no, right? So we did this trick, as it is given that these Barua numbers would be like this, like 1000, 100, 1000. So we are just counting all the zeros and taking them away. This we are removing this zero from the number, so it would be left out with only one for all the Barua numbers. Would be left out with only one. So you multiply one, you will get again one. Only part is this decimal number. Only one decimal number, which we need to take care. Like 0 anywhere we would move out, and whatever the non-zero part we'll just multiply. Okay, that we can easily store, right? That would be like within the limit. It would be given within the limit. Okay, Shreya, when it will happen? Okay, should we I don't know basically. Should we have okay, we had to do some quiz for competitive coding. What we can have actually, I'm not very sure of any quiz which we can have in competitive coding topic. So what we should have, like how the question would be like, what kind of question you would get in competitive coding? That should be the quiz question. In competitive coding, what are you asked to do? What is constraint in competitive coding? Kind of that thing I'll ask. Okay, so there's no quiz for this competitive coding. It's all about coding, coding, and coding. Okay. Okay, we understood this. Let's talk about one more question. If you don't have any doubt on this, till now, any doubt, guys? Have we missed anything, Anshika? Have you missed anything? Nothing, right? Okay, thanks.
No, sir, you have covered it all.
Okay, fine. Thank you. Actually, Jyoti, we are going with what is that? topic wise, like we are having quiz related to the topic we are discussing. That's why I'm not putting anything which is like not related to the thing which I'm discussing. Okay. So one more question, but this I would I'll like to have the answer from you guys. Okay. So let's say a stack is given to you. A stack is given to you. Obviously, there will be some elements. So tell me, guys, what is the time complexity for this push operation and pop operation? Who can say this? Ritika, if we talk about this course, like essential course, yes, whatever we have planned to cover, we're basically done. But we are now doing competitive coding, which is also a part of this thing, because competitive coding is also very important, right? You go for any interviews or maybe recruitment drive, so coding you need anyway, right? So that was about concepts. This is about applying the concept, where you would apply the concepts. Okay, so it is not about, I said in the very first day, it is not about only knowing data structure, it is about knowing where you can apply data structure and algorithm concepts. Okay, engineer Guruji says big of login, Abhijit says login n. Okay, yeah, it's very vast, Girish, you are correct. Satish says big of 1, and that is very correct. That is actually correct. Constant time, yes. Shikar, yes, you are correct. Constant time complexity. So push operation and pop operation takes constant time complexity, because you just have to take out the top element, you just have to put a new element at the top. It would just take big of 1. That is constant time complexity. So if your stack is given to you and a question would be asked to you, write down a logic to perform push operation, pop operation, and okay, find maximum element in the stack. So how to do it? If this is a question, write a logic to which would do push operation, pop operation, and find maximum element from the stack. We already know this push and pop, which is taking a big of a big of 1 time complexity. How much time complexity would be for this one, guys? This one, basically this. Yeah, find maximum element in the stack or minimum element in the stack. Just consider the stack as an array, because we are talking about the array implementation of stack. So what is the time complexity of finding maximum or minimum in an array, guys? Can you answer that question? What is the time complexity? Yeah, Shivansh, hello. Yeah, guys, you can say this one. Answer this, guys. Akash says big of n, finding out minimum element or maximum element in an array. So what we do basically in this kind of question, we take the first element of the array as the maximum element, and then we compare that element with every other element to check if there is any other element which is greater than this. If we find any other element greater than this, we'll make that element as current max. Then again we'll continue to do compare with the rest of the element. So we are comparing with n elements actually. Okay, we are total comparing n element. So this would take big of n time complexity. We have done already sort selection sort. So kind of same thing in each iteration, whatever we are doing. Okay. So if you talk about first iteration would give you the maximum element of the array. First iteration of selection sort, if you remember. Okay. So big of n is a time complexity to find maximum or minimum element in an array, and we are here talking about array implementation of stack. So this would also take big of n time complexity, right? The same way. But the question is, do it in big of 1. Push operation, pop operation, and finding max or minimum element in big of 1. Srikar, why not big of n square? Why it would take big of n square? We just have to compare this first element with the rest of the element of the array. So we just have to compare n elements. That's all. That would give us the maximum element. We just need one maximum element, right? Okay. So that would take just one loop, and so it would be big of n. But the question here is we have to find maximum element or minimum element in big of 1. Okay, big of 1. How can you do that? Can anyone like think of some idea here? Like how can we actually do this, fulfill this purpose in big of 1? Constant time. Okay, constant time. From big of 1, we need to do it in constant time, not log n, but constant time. Can anyone think about it? Just think about it a bit. And meanwhile, I would share our good old friend. We haven't seen it today, so it's time to say our good friend whiteboard hi. Otherwise, it would feel bad. Okay, so we'll go there and we would discuss this question over there. Okay, we haven't used it very long, so it is kind of taking some time. So just give me a moment, guys. I'm just sharing. So meanwhile, you can just think of some idea behind this, like how to do. And meanwhile, I think this will not be upset on us. This this whiteboard, and it would start soon. Double linked list. Yeah, Abhijit. Yeah, say hi to whiteboard. Yeah, actually, we can do that. We can say hi to whiteboard. Okay. Yeah. Whatever you do, like you say hi or hello to whiteboard, but meanwhile you think about the logic. How can we do that thing in big of 1, guys? That's the question here. Yeah, it has started. Now it's no more upset with us. Okay, let me get to the whiteboard. So stack would be given to us. Okay. Again, I need to check whether I can draw straight lines. I think I can draw it. Let's see. Fine. Like I have improved a lot. So 0, 1, 2, 3. Okay, yeah, fine. So this is an array given to us. Maybe the elements are maybe the like elements are 22. Okay, maybe not 22. I'll start with a different thing. Maybe 18, 22, 19, 25, 16, and maybe 15. Here it should be maybe 15. Then we may have let's say 16. Okay. Yeah, we have max function Amal, but well, let's do this thing. Let's do this thing because I need to understand. I need to make you understand the logic. Okay. See, again, I said in the very first day, it is not about the language which you are talking about. It's about all about the concept, the logic. Okay. So that it can be applied anywhere, any language you go for, C, C++, Java, Python. Okay, so it's more about concept and not about the language. So yeah, so stack. So this is a stack. So we'll push first 18, then 22, then 19, then 25, then 15, and then 16. Right. This is what we have. So two. Sorry, this one 2. This is 3, 4, and 5. Okay. So see this. So what happens basically? Do you think okay, who had said Amal Santosh? We have max function. Do you think max function like randomly picks a value and say you this is the maximum? It does some comparison, right? So obviously, if it is comparing inside, obviously it might be comparing with all the element, and at the end it would say, okay, this is actually the one which is maximum compared to all other techniques, all other values, right? So again, so it might be taking big of n anyway. So we don't want that. We need to complete it in big of what is that? Big of 1 constant time complexity. And one more thing also I need to mention you guys as we are talking about time complexity, also about competitive coding and all. Please remember Python execution will take more time as compared to your C or C++ or Java. Okay, it's like in this way. C will take the least time, then C++ will take, then C++, then Java, then Python. Okay, got it? And talk about the execution time, not the development time. Development time, of course, Python will take very less time. The processing time, basically the execution time. Yeah, this is the thing. So now I would like to find out the maximum element here. So I know by looking at it I can know 25, but I need to compare with all other elements, right? So we'll not do that because it will take big of n. So what we would do here is, see, actually we would take one more stack. We'll take one more stack. We can call that as max stack. 0, 1, 2, 3, 4, and 5. You can call that as max stack, sorry, max stack. This is our original stack. So this will have top and this will have max top. Let's say. Okay. So see this. We are talking about stack. Jyoti, given a stack, find out maximum element in the stack. Okay, we are not given numbers and some numbers are given and find out the maximum number between that. We have been given a stack. Okay. See this one. Yeah. So how to basically do this? Let's go in a proper man, like sequentially. So I'm erasing these values because I will be pushing one by one here. So first thing is 18. So 18 would be pushed here. Fine. Okay. This is the very first element. So just push it in both the stack. So obviously now top value would be 0. Even here it would be 0. Okay. Next we have to put 22. So anyway, 22 will be pushed here. Fine. Okay. Because this is normal stack, so you have to push the elements in order, whatever order is it is given. Okay. So next is like yeah. But before pushing into this stack, max stack, just see one thing. Check one thing. The element which you are trying to insert or push, is it greater than the uh, top of this stack? What is top of this stack right now? Top of this stack is 18. Whether the current element 22 is greater than the top of the max stack? Yes, 22 is greater. If 22 is greater, if current element is greater, then you push it. Otherwise, not. Okay. So 22 is greater than 18. So we push 22. Now this is the top of the max stack. This is max top, you can say. Again, so next number is 19. So 19 would be anyway pushed here because this is a normal stack. So we have to push every element. But here you have to check, before pushing 19, you have to check whether 19 is greater than the top of max stack. What is top of max stack? 22. Current element is 19. So 19 is actually less than the top of the max stack. So we'll not push 19. Rather, we'll push the 22 once again. Okay. This is the way in which we have to do. Next is 25. Yeah, 25 would be pushed here. Fine. But here, can we push 25? So we need to check whether 25 is greater than the current top of the max stack. What is current top of max stack? 22. Current element is to be pushed. The element to be pushed is 25. Yes, 25 is greater than 22. So we can push 25 here. So before pushing, you have to actually check this thing, whether we can push it or not. If we cannot push it, so just push the top element again, once again. Okay, like here 15. So 15, anyway I will be inserting here. 15 will be pushed here, and the next thing is, can we push 15 here? No, we cannot push 15 because 15 is less than the top of the max stack, that is 25. So what we have to do, we have to push it again. 25, we have to push 25 again. Next is 16. Okay, 16 will be pushed here. What about here? Can we push 16 in this max stack? No, right? We cannot push 16. So we have to push 25 once again. Okay, now see, if I now ask you what is the maximum element in this stack, you will just go to this max stack and print the top element. That's all. And you got your like maximum element of the stack will be big O of 1. Yeah, if you remember, Jyoti, in the first session, I said you have to trade off between time complexity and space complexity. If you want time efficient, then you might have to compromise with space. If you want space efficient, you might have to compromise with time. That's the deal here, and we are doing the deal here. Okay, we are trading off with this time and space. So we're taking more time, sorry, more space, so that we can have less time. That's all. Okay, so it's pretty much simple, guys. Simple, Jyoti. See, if you have 10 books and you have 10 shelf, you can put like each book at each shelf and you can label it differently. So directly you can go to that shelf and take it. But if you have one shelf, every book you will keep one above other, one above other. So you have to search. So it will take some time, extra time. Simple, very simple logic. Why we are pushing 25 two times? See, I'll say you guys, not exactly two times, but if you are not getting any greater element, we are re-pushing the top element till that point. If we get any greater element, then we push that element. Okay, not only two times or three times or one time. I'm not saying any number basically. Now you print the max element of this stack. You just go to this top of max stack and you print 25. Yes. Let's say now I'll pop some element. I'll pop this. I'll do pop operation. So what would be done? So this would be popped out. Even this would be popped out. Now if I ask you what is the maximum element in the stack, it's still 25, right? Top of max stack. If I now pop it, now I pop one more element. If I pop, so this would be popped, even this would be popped. If I ask you now what is the max top, so max element of stack, again same thing, top of the max stack, that is 25. Let's say I will now uh, pop one more element. So this would be popped out, this would be popped out. Now what is the current maximum? What is the maximum of stack? Same thing, top of the max top, that is 22. So now 22 is my top, like maximum element. So now if I pop 19, so I'll pop it from both sides. Now what is maximum? Same thing, top of the max top, sorry, top of the max stack, same 22. So okay. No, you cannot use a variable, Amal. If you use variable, then how would you, like, if you, when you pop out, then how would you know which one is the next maximum? Okay, how do you know what is the next maximum? So in order, maybe the question, like, let's say we'll pop out some element, then the question comes, what is the maximum element in the stack? So how to do that then? You have already deleted. One more stack and maintaining all the things, so that at every moment, even we do some push operation, even we do some pop operation, we'll always get the like max element at the top of max stack. Okay, original stack should be there, Divya, right? Because that is the order in which elements are given to us to push into the stack, push it into the stack. So original stack should be there. That is the actual stack. This is a auxiliary space we have taken so that we can do our operation in big of 1. This is the auxiliary space which takes big of n space complexity. So for this stack, our space complexity is big of n. And also because of this stack, we are getting time complexity as big of 1. Okay. I hope this is pretty much clear, guys. The concept. Yeah, Anshika.
Sir, I was saying that I mean, we have exceeded the time limit, so we
Yeah,
can
yeah, I got
continue
it.
this discussion further because it's
No, no,
never gonna
actually,
end.
we are done. We are done actually. Basically, we are done with the thing. We
Yes,
are done actually, basically.
yes,
So
sir.
we would close
So
it off.
yeah,
Close it off. Just give me a moment, like minute, and I would wrap the thing. Okay. Yeah. So
sure, sir.
guys, yeah, if anyone asking for this code, I think this would not be very much like difficult for you. Same push function, same pop function. Pop is basically simple. So in pop, you have to pop from the main stack, this stack, and also from the max stack. Just pop, do the same operation for both the stack. That's all. In the same function, you take big of 1, same thing. In push function, you push it to the original stack like we were doing. But before pushing to the second stack, this max stack, just compare, just check before pushing, just check what is there in the top of max stack, whether that is greater, or the element which I am going to push is greater. Whichever is greater, push that element. So just like a minor modification you have to do, guys. So nothing else actually. Okay, I hope you can do that after you know the push and pop operation, also the concept. I think you can do that. Okay. Okay, I think that's no more doubt in this. Just try it out, guys. And this question was asked in Amazon in some year. I don't exactly remember, but this question was asked in Amazon actually. So yeah, so there are many questions actually. I cannot discuss all the questions right now, right here with this time person already. Anshika has given red alert, so we have exceeded our time and we have to end this thing. Okay, so we cannot like, I cannot give you like we cannot go on discussing this thing. There are a lot of things. We will cover that in our advanced course, guys. Okay, yeah, Anshika, we can wrap it up now. You can like have a word with them.
Okay. So, guys, we have a special only competitive coding session, and you don't have to miss it. So, it's on Monday, same time, 6 p.m. You have to be present there. And once you have the course is about to finish, and you have seen all the concepts that time, so you can all brush it up again, revise, keep revising, and try to learn new concepts from Google. You know, you have a lot of stuff there out. And yeah, so get yourself prepared for the exam. So see you next time. Bye bye. Take care. Anything would you like to add, sir?
Nothing. Just try to do this, guys. Like I hope you can actually do this. You know, you now understood the concept. Just try to implement it. If not possible, we can like have a discussion on Monday again, as Anshika has said. Okay. So yeah, guys. So thank you for bearing me for so long. Actually, I have also taken some extra time of yours. So thank you for giving me that. Also, I hope that we have like understood. All of us are on the same page now. I hope that. Okay. So yeah, guys. So thank you very much. Let's meet Monday, same